Okay, so this week we finish off our last part of analysis of variance. And the last part we'll do is to look at extending the between groups analysis of variance to include not one independent variable, but two. You can have, I call it n-way because you can have basically you can have more than two independent variables. I'll show it in a second. So the independent variables are the ones that I kind of like manipulate, group membership, my treatment, and then the dependent measure is what I'm measuring my participants on. Okay, so what we're going to do this way, because we're going to look at the two-way analysis of variance, or two-factor ANOVA. We'll set up the hypotheses. We'll walk through the calculations of the sums of squares for the source table for the two-way ANOVA. And then we'll complete the source table. That will be for this week, and then next week we will go through what we do after we have rejected the null hypothesis for the inferential test that we do for our two-way ANOVA. Okay, so the study I'm going to introduce for the example two-way ANOVA that we're going to use for this part of the course. My two independent factors are going to be incentive type or financial reward and training type. So what I'm doing is I'm looking at developing a tutorial for introductory statistics. And not only do I want to test the effectiveness of the tutorial I've set up, but I'm also looking at seeing if I give people a financial reward, a bursary for passing statistics. So what I end up doing is I have two independent variables. The independent variables are financial reward. Half the students in the study get a $1,000 bursary for passing statistics. The second half receive no monetary incentive or no monetary reward. So that's one independent variable. The second independent variable is training type. So for each of my financial reward levels for that variable, for example, for the ones who received a $1,000 bursary for passing the course, 1/3 of those participants received no additional support beyond what was provided in the course outline. 1/3 of them participated in a one-day stats training seminar retreat in Las Vegas, fully covered by Georgian College. And the other final third participated in a one-day stats training retreat at Georgian College. We were not remote. You're coming into the Georgian College, into the lovely campus, to spend 12 hours intensive stats exam prep with me. So, and that's for the ones who receive the financial reward, the $1,000 bursary. For those who do not receive the $1,000 bursary, receive no money. I got no money. Of those group, I've split them into three. And of the ones who received no financial incentive, a third received no additional support, a third went to Vegas, and a third hung around the college and did the intensive tutorial work with me in a lovely Georgian College lecture room. Okay, now these are independent groups, right? This is a between subjects design. So every group I've talked about are separate, distinct groups of students, a group of students. Okay, my dependent measure, I go through this study, and I take my people, assign them, my students assign them into the respective groups that make up the study. And then once we're done the course, I measure them on, my dependent measure is their final course grade. Okay, so that's my design. Okay, so here's what it looks like in terms of just putting it into a little matrix for you visual learners, myself included. So, so I have those who receive, and they receive no money. And of the ones who receive no money, no bursary, I had 15 subjects, 15 students. And of those 15 students, 5 received no additional training. 5 of them went to Vegas with me, and 5 of them stayed at Georgian College and did the training session with me. Of the 15 students who received the money, 5 of them get no training. 5 get Vegas, and 5 get Georgian training. So overall, I have 30 subjects in my study, right? This is a between subjects design. And I randomly assign students into each of those little boxes. So I randomly assign 5 into the no money, no training, 5 into the no money Las Vegas, and then 5 into the no money Georgian. And then for the ones who receive the money, 5 of them get no training, 5 get Vegas junket, lots of fun. They go to a show. It's a great experience. Trust me, I've done it before. It's lovely. And then 5 of them did the boring old Georgian tutorial session in some classroom with uncomfortable chairs and ugly concrete walls and no windows and ceiling tiles that are kind of stained from water damage from leaking. Real nice. We're in the nice, lovely old E building. A lovely campus. Okay, so that's my study. That's the design. Random assignment, because we love random assignment, makes it a true experimental design. Okay. So I run my study and I collect my data. My dependent measure is final course grade. And here is the data for my 30 subjects. I've split them into 2 separate tables. One table is for those who received no money. The other table is for those who received the money. And of the ones who are eligible for the no money, I have the 5 who had no training, the 5 who went to Vegas, and the 5 who stayed in Georgia and did the tutorial. Similarly, for the ones that received the money, they received the bursary. 5 no training, there's their final grades. 5 Vegas and 5 Georgian. So you can see my design. I've got 2 independent variables. So I have the condition money, no money, money. And I have the condition training, no training, Vegas, Georgian. And you can see how for the no money and the money, on the training side, they kind of mirror each other. 5 no training, Vegas, Georgian. So I have a nice design. I have 2 independent variables, and I'm off to the races. Now I have to do my two-way analysis of variance. Okay. First, to look at my results. So I can see that for the 15 students who received money, and of those 15 students who received money, remember that 5 of them went to Vegas, 5 of them did Georgian, and 5 of them no training. So of those 15 students, the course average was 70. For those who received the no money, and that was 15 students, and that's made up of 5 no training, 5 Vegas, 5 Georgian. The course average was 60. So the results suggest that receiving a $1,000 bursary for completing stats seems to be a good motivator, because those who receive the opportunity to receive the $1,000 bursary for passing stats, and they get paid, the course average was 70 for those 15 students and 60 for the ones that received no money. Okay, now let's look at our other independent variable, or factor, and that's training program type. Now, for the no training, the course average the average grade for final grade for the no training was 65. Now remember that the no training is made up of 5 students who received no money and 5 students who received money, right? Because if I go back, if I look at the no training, 5 students who had no incentive offered, and 5 students who received had the money. So I have 10 students. Okay, so 10 students made up the money group, made up the no training group. 10 students made up the Vegas group. 5 no money, 5 money. And then the Georgian group is made up of 10 students. 5 no money, 5 money. And as I can see from here, those who had the Georgian session with me, that was the highest course average. That seemed to be the best training program. No training, that's kind of like the control group, mean of 65. Going on a Vegas junket, you got free shows. I had the Adele tickets, but that fell through. It was sad. She was crying. It was a mess. That was the worst option. That was just too much of a distraction. It was a lot of drinking. So 60. So I can see that if I'm going to offer training, the best training to offer is Georgian. And if I'm going to give an incentive seems to work. Okay. Now I could have run this as 2 separate studies. I could have just run it with, run an evaluation, see what the effect of offering a bursary is on final grade in statistics as one study. I could have run a second study and looked just solely at the impact of training. So I could have done this as 2 distinct separate studies. There's nothing to stop me from doing this. But the beauty of it is combining the two factors into one design or one study allows me to look at an interaction effect. And an interaction effect is say, well, what is the impact of training for those who received a $1,000 bursary for passing stats? What is the impact of training for those who received no bursary? That's an interaction effect. And that itself can be quite interesting and quite useful. Let's see what our results show. It's a pause for dramatic effect. Well, what do we find when we look at the interaction between the two factors? For those who received a financial incentive, there is no effective training, right? It's like a ceiling effect. So for the 5 students who received a $1,000 bursary and had no training, the mean was 70. For the 5 students who went to Vegas and received the bursary, the mean was 70. For the ones who did the Georgian training and received the bursary, the mean was 70. So the blue line is basically a flat line. But now when I look at the people who received no financial incentive at all, so they had no additional motivation, the mean for the no training, those 5 that received no training and no money, was 60. No money Vegas group, those 5 students, the mean was 50. Oh, that was brutal. And then for the Georgian group who received no money, the mean was 70. This is what I would refer to as an interaction effect. And what it tells me is that the impact of training is dependent upon whether or not you received a financial incentive. So when I look at my results and I can look back and I can say, okay, here's the main effect for training. Georgian better than Vegas, and Vegas the worst. No training in between. The main effect for money. Those who received a financial incentive, the average was 70. And those who received no money, the average was 60. These two effects are marginal to a significant interaction. So while amongst my 30 students, the 10 who received no training, 65, the 10 who received Vegas, 60, and the 10 who received Georgian, the mean was 70. The key is this effect here is conditional or marginal to the interaction, because the effect for a training program type only occurs for those who received no money. That's an interaction effect. And that's the beauty of a two-way analysis of variance. I can look for the impact of two factors combined or crossed. And I can say here, yes, I can have an incentive effect. I can have a training effect. But what I can see is when I combine the two factors into one study, I see an interaction between the two. And what I see here is that when there's no money, there is a training effect. And when there is no incentive or bursary offered, there's a very powerful effect for Georgian training. So the Georgian training is quite impactful in a sense. It led to the greatest improvement. Why is this important? Well, I can clearly see that getting a $1,000 bursary is very effective. And it's so effective that it kind of like blurs out and gets rid of any possibility of a training effect. So even if you go to Vegas and party on for the weekend, you're still going to get 70 because you've got your $1,000 bursary opportunity. Where this is important is I can go to the college and go, well, you give a $1,000 bursary, and let's say there's like 60 students, and let's say 60 of them pass. That's going to cost you $60,000 to basically help bump up their stats grade, because stats is so important to research, so important. That's very expensive. I can show them this chart, this graph, and I say, look at that over here. Look at these for the no money. It hasn't cost you college, president. It hasn't cost you anything. Or Dean, especially Dean Tim. It hasn't cost you anything. And yet, if you run a Georgian session with me on a Saturday near the end of the course, that's highly effective. That's as effective as giving it a financial incentive. Now, that financial incentive is going to cost you around $60,000. And I can go, you know what? I'll do it. I'll give you a break on the cost. I'll run the one-day training session. I'll only charge you $10,000 for the one day. I'll provide all the materials. I'll even provide refreshments and lunch. It won't be much, but so I can do it for $10,000. That's going to save you a ton of money. That interaction is what drives that decision making. So the interaction is, okay, $1,000 incentive, that's great, it works, it's very powerful. It's going to cost you $60,000. But go with the no money and offer the training session and force them to come in on the weekend for that one day with me in that concrete block building with, oh yeah, it's very dry too and very warm. There's not very good air circulation. That's very effective. And I can do it for a lot cheaper. And instead of the money going to the students, the money goes into my pocket, which makes me very happy. Okay, so now that I've kind of like shown the results and kind of like revealed what the findings are, the question is, what's the path that we take to complete the analysis? Well, we're going to do an analysis of variance. We're going to create our source table, just like we've done with the one-way and the repeated. We'll have different sources, and we'll have a total sums of squares for the study, for the analysis, and we partition that into the different sources that make up the analysis of variance. But first, one thing I just wanted to also, just an aside, the interactions can be funny. This is not our data, but interaction, you can have no effect for money, hypothetically. So this if I achieve different results. No effect for money, and you can have no effect for the main effect training. But even though you have no main effect for training or for the incentive type, you can have a significant interaction. This is a completely crossed interaction. And we didn't get this finding, but I just wanted to show that sometimes the interactions are quite useful because they can reveal an effect that if you had run it as two separate studies, you would not have seen. Okay, that's just a nice aside. So it's back to our real data. Okay, so once again, this is a between groups, right? So total variability is between groups variability and within groups variability. Within groups, we refer to error. The between groups, within groups, the between groups we sometimes refer to as treatments. And in this case, treatments is actually not a bad term to use because it actually is a treatment. You're either getting money, you're not getting money, or you're going to get some form of training, vagus, Georgian, or you're going to get no training. Okay, and my between groups or treatments variability is composed of variable A, which in this case I'll refer to as incentive type, and variable B, which I will call treatment type, and my interaction effect between A and B. A being incentive type, B being training type. Okay, typically when we talk about analysis of variance where it's n-way, we use the capital letters for the different independent variables that we have, and we start with A, B, C, and such. Okay. Now, once again, as we know, the analysis of variance is an omnibus test, and I mean omnibus. It shows that there's an overarching effect, but it's not specific. It won't tell me specifically where the differences amongst the means reside. All I can say is that the variability due to the between treatments is greater than the within or error variance or variability. So variable A, all the mu A's are equal, and for variable A for us, it's going to be incentive type, and variable B, all the mu's are equal for the main effect, and then for the interaction between the two factors, the mu AB's, this is where I have them crossed, are equal, right? So in this case, there's two levels, incentive or no incentive for variable A. For variable B, there's 3 levels, right? For the overall main effect, there is no training, vagus, and Georgian. And then for the interaction between, or the crossing of A and B, there are 6 means, right? I have 3 means for the no money, no training, vagus, Georgian, and 3 means for the money, no training, vagus, Georgian. So there's 6 means overall. And in this case, the null hypothesis is all 6 means are the same. Okay. Sums of squares. Now I've had to add an extra summation sign when I do my sums of squares total. I got to do it for each level of A. So no money, money. And then if I'm focusing on, say, no money as level A1, I got to go through all 3 levels of the training type. And when I click through those, I got to go through each of the 5 people, or the little n, for that specific group. So my little n in this case is going to be 5, right? Because that little n is the number of people within a closed set that are kind of collected together. So no money, no training, there's 5 people collectively in that group. The overall mean for the study is 65. So for the total sums of squares, which is what we've been doing for the one-way and the repeated, I just take each individual score. I have 30 of them. I subtract the grand mean from each of those scores and square it. I've done that here. Sum it up, and it sums up to 2,216, right? Okay, my between groups, I've got 3 null hypotheses. I got the null hypothesis for the main effect for A, the null hypothesis for the main effect for B, which is training type, and then I have my interaction between the 3 factors. And there is also a overall between groups sums of squares, which is basically just each of my 6 means minus the grand mean squared. That calculation, do that for the 6 means that I have, multiply it by the 5, which will give me the total. I can have a total between group sums of squares, which further partitions into the main effect for variable A, main effect for variable B, and the interaction between the 2 variables. Now the only thing, everything stays relatively the same. MA is just, the mean for each of my levels of incentive type. I have a mean for the money people, a mean for the no money people. The only thing that looks a little tricky in here is this NB here. NB refers to the number of levels of variable B. Now I have 3 levels to variable B. I take the 3 and I multiply that by the 5, right? 5 always refers to a closed group of 5 people that are collectively the same in terms of where they are in the study, as no money, no training, or whatever. The reason I take the 5 and multiply it by 3 for the main effect for incentive type is for the mean of A, I have 15 people, right? So if I go back here, for the no money people at the bottom here, there's 15 people, right? There's 5 people within the no training, 5 people in the Vegas, 5 people in the Georgian. So I got 3 levels of variable B for the no money. So I take the 5 here and multiply it by 3 to tell me that I have 15 no money people. That's where the B comes from. B represents the number of levels of variable B. There are 3 levels to variable B, and within those no money people, there are 5 people that are no money, 5 people that are Vegas, 5 people that are Georgian. So 5 times by 3 is 15. Similarly, when I go for my training program type, I take my little 5 and multiply it by the number of levels of variable A. There are 2 levels. So I have 10 people per training type for the main effect. I have, for the example, for the no training, I have 5 people no money, 5 people money. So 5 times by 2 is 10. And where does the 2 come from? There's 2 is the 5 people for no money, and the second is the 5 people for money, right? So 5 times by 2. That's kind of that's why that kind of looks a little funny. The interaction effect is just this. That's that ugly formula that we did last week for the error term for repeated measures. It is simply it's an interaction effect. It looks ugly. Once I lied to you last week and said that it was going to be the ugliest formula that you see. Well, that's a bit of a half-truth. Looks ugly, but whereas for the repeated measures, the error term is the interaction between subjects and treatments. And I got to do that for all the people in the study. For the interaction effect for the analysis of variance, I only have to do it in this case 6 times for each of the means. So I do for 6 of each of the means. So if let's say I did the mean for money, no training, I take the mean for the no money, no training, subtract from it the mean for the no training, subtract from it the mean for the take the mean for the no money, no training, subtract the mean for the no money, subtract the mean for the no training, and add the grand mean. Do that for all 6 means, multiply it by 5 because I have 5 people per group. And once again, the interaction effect is, it's an interaction effect. It's an ugly formula. And let's just kind of, we've got to grind through it by hand. That's what it looks like. So here's my simple calculations, right? So here, the mean for the money is 70. The mean for the no money is 60. I have 5 people, and I have 3 people per level for group B. So I take 70 minus 60 is 10. 10 squared is 100. Oh, the grand mean is, sorry, the grand mean is 65. Sorry. So 70 minus 65 is 5. 5 squared is 25. 60 minus 65 is minus 5. Minus 5 squared is 25. So then I have 50. So I sum them up. The 25 plus the 25 is 50. 50 times by 3 is 150. 150 times by 5 is 750. That's that calculation. Then I have to do the calculation now for the main effect for training type. So 65 minus 65 is 0. 60 minus 65 is minus 5 squared is 25. 70 minus 65 is 5. 5 squared is 25. So then 0 plus 25 plus 25 is 50. 50 times by 2 is 100. 100 times by 5 is 500. There's where my sums of squares for the effect for training type. And then I do my ugly calculation here. So I'll just walk through the example I have here. I take the money Vegas, which is 70, minus the mean for the money, which is 70, minus the mean for the Vegas, which is 60, plus the 65. So I do that calculation. So let's just walk through it. Let's see if I can do this in my poor my brain. So 70 minus 70 is 0. I then have a minus 60 plus a 65, which ends up with plus 5. Plus 5 squared is 25. Times by 5 is 50. I got to do this calculation 6 times. So I got to do it for each. I did the Vegas money, and then you could also walk through. I'll walk through it in Excel in a sec. So, and then this one here you don't really have to do. It's just simply each mean minus the grand mean squared. That total sums of squares, which is the bottom row here, is 1750. And all I'm doing, you won't use it you won't see it in the source table and for an analysis branch, particularly like in an SPSS. But all it's saying is I have this total between treatment sum of squares or between group sums of squares. It is partitioned into 3 pieces. The main effect for A, which is incentive type, 750. The main effect for training program type, which is 500. And then the interaction between incentive and training, which is 500. So 500 plus 500 is 1,000. 1,000 plus 750 is 1750. So the only reason I'm presenting it here is, once again, analysis of variance is simply partitioning of the total sums of squares. And then it's sub-partitioning. Here's my total between treatment sums of squares. It's further partitioned into really my 3 key sums of squares, right? The main effect for incentive A, main effect for training B, and then the interaction between the 2 factors. Okay, we're off to the races. This is just a summary of the different calculations that made up that total sums of squares for between treatments or groups. Once again, I'm using these terms synonymously. I do apologize for any confusion that may cause. The error stays the same as we've done before. It's basically take each individual score, subtract it from the mean for that particular group for that the person is from. And that group would be, for example, no money, no training, no money, Vegas, no money, Georgia. Right? Take that from the mean that for the 5 people that make up the mean for the group that they're from, square it and do that across all 30 people. My error ends up in the calculation is 466. You can refer to the Excel spreadsheet that walks through this. You can see the calculations in Excel. I'll show that in a sec. So there's my total sums of squares for the whole study. So 750 plus 500 totals to 1750 plus the 466. If I add the 1750 and the 466, it adds up to my total sum of squares of 2216. Each of those calculations was done independently of the others, and everything in terms of accounting adds up. It's always good that if you're doing this and you do it by hand, that when you check your calculations, make sure your sums of squares sum up properly and everything adds up to the total sum of squares. It's always a good audit check to just kind of do them separately and make sure everything's kind of like kosher. Degrees of freedom, quite simple. The degrees of freedom for group A is the number of levels of group A minus 1. In our case, we have 2 levels to incentive type, money, no money. 2 minus 1 is 1. The degrees of freedom for treatment B, which is in our case the training program type. There's 3 levels, no training, Vegas, Georgian. 3 minus 1 is 2. And then the interaction between the two is simply a crossing of the degrees of freedom for A incentive times by the degrees of freedom for training. So 1 times 2 is 2. The overall degrees of freedom for between treatments is the number of levels of A times by the number of levels of B minus 1. So 2 times 3 is 6. 6 minus 1 is 5. And as I can see, whereas I partition the 1750 into the 3 sums of squares for the main effects in the interaction, similarly, the total degrees of freedom for the between groups or treatments, the 5 is partitioned into the 1, 2, and 2 of my 3 sources that are between treatments. The error degrees of freedom is simply n minus 1. I have 5 people within each of my groups being crossed by training incentive type and training, which is 5 times 1 is 4, multiplied by 2 times by 3 is 6. So 6 times by 4 is 24. Total degrees of freedom is the grand N for the study, which is AB times by N. So 2 times by 3 is 6. 6 times by 5 is 30. 30 minus 1 is 29. Beautiful. And then we walk through our mean square error, which is similar to what we did with our previous source tables. Calculate my F observes. And then my F criticals, which can be different depending on the degrees of freedom. And I can see that I reject the null hypothesis in all 3 cases. Okay. So to test the success of the 2 forms of intervention, we had the financial reward, and then we had, per financial reward, we had the 3 levels of treatment, just to summarize. And I write this up. A 2 incentive type by 3 training program type analysis of variance was performed on the variable student final grade being my dependent measure. The analysis revealed main effects for both incentive type and training program type. The 2 main effects were marginal to a significant interaction between the 2 variables. Once I'm using the word here marginal, which is the go-to term. So what I mean here is that the 2 main effects become uninteresting once I have a significant interaction between the 2 variables, my 2 independent variables, right? I'm not really interested that there's a main effect for incentive type, and I'm not really interested in a main effect for training type, because as I saw from my data, the training effect only occurred for the people that received no incentive. So I got to talk about the interaction, because it's the interaction that's actually interesting, and it would be misleading to just focus on the 2 main effects. Okay, now that ends this part for this week. So in Excel, I have for you the calculations for the source table. So I'm not going to go through it here, but you can see where the different means have been calculated. Don't care about that error. I also have it for the training. Here's the number of people, right? And here's the N by B in terms of how many money people I have, how many no money people I have, which is important for the sums of squares. Here's each of the calculations for the sums of squares. You can walk through how I did it. Minus K6. Where's K6? Oh, there's K6, the grand mean. Okay. So you can walk through them. I did take a little shortcut for the SS error. I got a little lazy. As you can see what I did. I just took the variances from each of my groups. Where did I pull that from? Oh yeah, here. So I took I took a little shortcut. You can check it if you have any questions on that. Then I have the results from SPSS. Running it through SPSS. Here's the data. Analyze general linear model univariate. Let's reset. My grade is my dependent measure. There's the grade here. My fixed effects, which are my independent variables, are incentive and training. And I'll just leave everything as is, and then boom, it'll give me my source table. Once again, SPSS produces and gives you a lot of crap that you don't need, and it'll look funny. It's got a corrected model sums of squares and an intercept sums of squares. We're not going to get into it in this course, but really what this is multiple regression. It's a funky form of multiple regression. I've approached it and taught it from a sums of squares perspective, which I think is easier to understand. We're not getting into the matrix algebra, and we're not getting into it as a regression model. So you're going to see weird stuff. Like you're going to see an intercept. Like if you remember from simple regression, your y-intercept. There is an intercept for this, but the key thing that we want, so we don't need all this gobbledygook from SPSS. We see our F reward, which is incentive type 750, training 500, interaction 500, and our error of 466, which replicates what we did by hand, and we can see our three Fs that are key to us. The F reward, F of 38.627, and then the training, and then the incentive by training interaction, right? So this table here, as I can see from my Excel, replicates our source table here, and here's our source table. Okay, so that's it for this week. There is a practice question. You can do the practice question. It shows the results. It's got a start table for you in Excel, and you can see the final results. There's also a video that walks through the practice. Go to about the 13-minute mark, because I have the whole thing, which is what we do next week, is after that 13 minutes of that YouTube video. I apologize for some of the poor sound quality on that video. That ends it for this week's class. Next week, we get into what do we do after we have a significant interaction. And what we'll do is we're going to do what's referred to as simple main effects, and then we'll do post hoc tests. We won't be doing any plan comparisons for the two-way analysis of variance. That would just be, I guess, we could do it, but I don't want to torture you anymore. So that's it for this week's class, and enjoy the practice question.